Alright everybody, welcome back to Let's Code a Web App. This is video 3, and I already have my code pulled up. I'm going to do something a little bit different now that we're starting on the actual application development. I want to make sure that I'm doing this sort of live. Behind the scenes, I am trying things out, seeing what works and what doesn't work, so that these videos aren't just terribly long. So what I've done is I've created an almost blank file. I'm going to call this accountingbeginning.lisp, and hopefully we will try to get to the accounting.lisp file or something close to it. I may choose different names or something. I am only human, but hopefully that is what we will do. So I'm going to clear this buffer out so that there's not a bunch of things in the way here. And great. So in accounting, you collect transactions, you debit from some accounts, you credit to other accounts, and the format that I want to use, the data structure that I want to use for tracking these transactions is something called a property list. And I have a little bit of an example here. Let's just go over it. So property lists are symbols followed by values. So here I have A1, B2, C3, some things like this. And this is just a list. It's a list of symbols followed by values. And it's sort of like a very, very small hash table. I am mapping the keyword A to the value 1. I'm mapping the keyword B to the value 2, things like this. For less than about 20 entries or so, I think it's actually, in some Lisp implementations, it can be much more. It can be more like 200 entries. These lists are much more efficient than hash tables. You know, hash tables require a lot of overhead, even though they're sort of O of 1 lookup, and these are kind of O of n lookup. These are more efficient. The way that you use them, so let's just set f property list like this to this property list that I just made, A1, B2, C3. And usually you do want to use keyword arguments so that you avoid some weird errors with packages and oh, yes. That's right. So this is warning me I'm setfing a thing that doesn't exist. I have to create it first. And so I have to say def parameter property list A1 B2 C3. There we go. Excellent. So that is our property list. And we use this function called getF. We put in the list that we're getting our value from, and then the indicator. So A, and this will tell us that A has been mapped to 1 in this list. And furthermore, this is a setfable place. So setf, like I said, doesn't just assign to variables, it assigns to generalized variables or places. So if I get f a, and so I'm going to just setf this, instead of a being 1, I want it to be 5. I can set it like this, and now we look at the property list, and now a has been mapped to 5. Okay, excellent. So this will be a good format for storing our transactions, I think, at least because it's very descriptive, it's very human readable. It's our transactions, you know, they really only have 4 values in them. So using a hash table is a little bit of overkill. Using a structure might work here, but I think I want to show you the motivation behind using a structure. I don't think that we should automatically jump to using structures and objects. So I'll show you a little bit of the motivation that a structure can kind of do the things that we're going to have to do by hand to do this with a property list. But I think a property list is just fine. So if this is the format that I've documented here for our transactions, date is a UTC date. These are stored as integers in C, you know, sort of C dates or Unix dates from the Unix epoch, that kind of thing. It's the number of seconds since January 1st, 1970 or something like that. We'll have to do some work with that. But, so if this is our transaction, well, I just want to, instead of having a bunch of excuse me, instead of having to write this out, to write this getf thing out every time for my transactions, that's kind of annoying. So I'm going to define functions that abstract this away. So we'll say transaction, no parentheses, transaction date of a transaction. And this will just be getf transaction date with the keyword argument date right there, just like that. So, that's great. And I can define the same thing for transaction credit. So what account are we crediting? Well, like that. Same thing for the debit. And finally, I put this as credit account and debit account in the specification here. And find then transaction amount of a transaction is just in its property list is the amount. And that's great. So now, finally, we want to just have a function that can just take these arguments and make a transaction. So make transaction. I'm going to make these keyword arguments so that they're more sort of human readable, and it doesn't matter the order that they come in or something like that. So date, credit account, debit account, and amount. Sort of pretty print this a little bit. Do something like that. That looks better. Okay. And, oh, well, it undid it. Oh well. And we will say, and this will just be list, date, credit account. So when I have a keyword argument, I'll show you how to invoke a function with a keyword argument. Debit account, the debiting account, and amount. Oop, misspelled that. Amount. Okay. Excellent. And I'm just going to make a in the REPL I'm going to make a keyword test and key, and we will say, we will allow keys for A, B, C, and D, and then just list them out like this. So what this is doing is keyword test. Instead of just saying 1, 2, 3, 4 for A, B, C, and D, I have to specify. I have to say, well, A is going to be 1, B is going to be 500, C is going to be the string ASDF, and D is going to be, 65.3. Okay. And then this will assign, wherever I put the A, it will become 1 in our function. Now A is going to be equal to 1 when we pass it to it. And I don't have to put these keywords in the same order, so I can put A over here, and it's the result is the same, because when Lisp compiles this function call, it's just going to match up the keywords to the values that you supplied for the keywords and substitute those in for the names of these variables in the function execution. So that is how keyword arguments work, and the reason we do this isn't to just be obtuse. We certainly could just not use keyword arguments, but then you sort of have to memorize the order in which you supplied these arguments. So you have to say, okay, first I do the date and then the crediting account. Oh, does the debiting account come first? Slime helps with that, of course, but you can also just use keyword arguments, and it's eminently clear wherever this function is called in your code what the parameters you are passing to it mean. So that's it. So this is just a make transaction, and again, this is just a property list. So we're going to use this list function that I went over in the last video to make a list, keywords followed by values. Very simple. So let's make a transaction. A date, you can say get current date, I think is the name of this function, or get, I forget how this date works. It doesn't matter, as long as it is an integer. it should be acceptable. So we'll just supply that. The crediting account, let's say we'll credit our opening balances account, something like that. Debiting account, and I'm using symbols here just because they're the easiest to work with right now. I think probably in the future we will move on to strings instead, so they can be a little bit more general. We're not, you know, interning a bunch of a bunch of symbols and blowing up the stack and things like that. But debit account, we'll call this checking, and now in the amount of $2,000. And this is just, oh, that's right, I forgot to compile this. I'm going to compile this whole file with Control-C, Control-K. That compiles an entire file and loads it, by the way. And there we go. And it has made this transaction in the exact format that we like for it. That's excellent. Alright, excellent. I just had to look up something very quickly about getting the date so we can make this a little bit better. And so instead of date, we will use a function that comes with Common Lisp called get universal time. And then, you know, we can do the same thing. And this will be a little bit more idiomatic. Checking in the amount of 2,000, and we've made basically the same transaction. This is what a date integer looks like. You know, it's sort of a quirk of Unix systems. Okay, excellent. So that's making a transaction. Well, now we need to add a transaction to this general ledger, which will just be a repository for all of the transactions that our user is making. You know, in the future we might want to support multiple users, so we'll need multiple general ledgers, and we'll have to probably use a database system or something like that for that. But for right now, I'm just going to use a global variable. Just going to use this global variable called general ledger. I put asterisks around it. Those are called earmuffs. They just mark this as a dynamically scoped variable, and we can get into a little bit later what dynamic scoping means in Common Lisp and why that's important, but you want to mark these global variables off with these asterisks. All global variables in Lisp are dynamically scoped, and it's important to remember that, so we mark them with these asterisks or earmuffs. Great, so now let's see. Define add transaction, and this will just push, we'll just use the push function. We'll just push the transaction onto the general ledger. And a stack works fine. I think having the most recent transactions first is very useful and worthwhile. So that works. With keyword arguments, you can specify initial values. So you can specify implied values. So if I don't supply a date, I just want you to invoke this function get universal time, and we'll just assume that now is the date that I would have supplied if I had supplied it, but I'm just, you know, just a little too lazy to do that. So we do that, we put date and its initial value all into the same list, and that makes it into an optional keyword value and if I don't supply this date keyword, then it will just invoke this get universal time function and use that value. That should be very important. So let's check this out. So Control X, Control E to add the add transaction to it. So let's do add transaction, make transaction. I don't have to supply a date anymore, so we'll just say credit account, opening balances. The debiting account will be the checking account in the amount of $2,000. I forgot to close that out. Great. And, oh yes, I need to recompile. This make transaction. Reset the general ledger to nothing, and there we go. So we didn't supply a date, but we can see the date was made, and it was set to whatever the current time was when I invoked that function. Excellent. So that's how we add a transaction to the general ledger. Well, this is all great, but one last thing is I want to be able to just get the balance of my account. I want to, you know, so I do this, I can add a couple more transactions. So let's let's make another transaction where the crediting account is the checking account. Let's say, now I'm going to debit a gasoline account. So say I get $50 worth of gasoline, so I add that, and then make another one where I spend some more money, and I get some books for another $50. Unfortunately, I do have a very bad habit of buying a ton of books. Okay, usually not $50 worth at a time, but it certainly happens. Let's see. Well, and then I get paid, So I am going to credit my wages account and debit my checking account, and I get paid. Whatever I get paid. I get paid $500 or something, and there we go. That is quite the register. But now I've sort of lost track of how much money I have in my checking account between all of these transactions. So let's say define account balance of an account. And by the way, putting the thing that you were taking the action of followed by the action is an extremely idiomatic way of naming your functions. It's very descriptive, very easy to read. Unfortunately, not so easy to type out. But, I mean, how much of your time coding are you spending typing anyways? Most of it you're spending thinking. If you can think fast enough to type English sentences about your coding, then I think you can think fast enough to type coding. So, even with very long variable names. Okay. So account balance, and I'm going to, well, let's start out. Let's let the balance be 0, and we'll sort of accumulate. So we're going to loop for each transaction in the general register if either of the accounts are involved. So if either of the accounts are involved, so it could be either the credit account or the debit account, right? So if the transaction debit of our transaction is equal to the account that we're looking for, and EQ tests for symbol equality. You don't really use EQ for numbers, especially don't use EQ for numbers. It will give you the wrong result most of the time. But EQ checks, so, EQ checking, if we go over to the REPL, will return true, but EQ checking, saving will return false. But EQ11, it returned true in this case. Sometimes it will return false depending on how your implementation goes. It's a poor idea to do that. So if the debit transaction of the account is, then we need to accumulate it. Accumulate transaction. And this just means make a list of all the transactions that fit this test and return it. Let's do this, and it'll look a little bit nicer that way. Okay. So that's what this accumulate keyword in the loop macro is. Okay, if those are equal, do it. But we also need to do it if the transaction credit is equal to our account. So we have the same thing going on over here. Transaction credit, transaction account. Oh yes, I forgot that we are not making a ledger for an account. We're trying to check the balance. So we don't accumulate the transaction. So we'll say do, and then setf balance, and then we're going to add to our balance something like the amount in the account. Now, sometimes we have to subtract the amount, and sometimes we have to add it. So when do we add it? Well, we add it when our account is the kind of account that increases with debits, and this is a debiting account, or it's the kind of account that increases with credits, and this is a crediting transaction. So how do we check that? Well, we're going to have a couple of if statements, and instead of doing that, I'll probably say a cond. So if, and we'll have to supply some sort of argument to this balance. Say we'll call this a key argument, increasing with. So if it increases with debits, so increasing with debit, increasing with debit, if it's increasing with debits, and EQ transaction debit, our transaction is the account, sorry. So if this is the kind of transaction that is debiting our account, and this is the kind of account that increases with debits, then we're going to increase it, and this will have to be an and. I know this is getting very long, and I think I can show you a better way of doing this than this, but or if the opposite is true, and it's increasing with credits, and and this transaction is crediting this account of our transaction, the transaction credit of our account is the account. In either of these cases, then we're going to add balance, account balance of the account. Transaction balance. Transaction amount, I think is what I called it. Transaction amount of the transaction. Because we said for transaction in general register, that's right. Otherwise, that's right. I got the cons. Actually, we can just do an if instead of a con. So if this is true, then that's the amount that we will do. Otherwise, we have to take the negation of it. And you can negate a number with just the minus. So minus 1, 2 is 1 minus 2. Or minus 1, 3 is 1 minus... Oh, no, that's not what I meant to do. Minus 1, 3 is 1 minus 3, so that will give you negative 2. But just minus and 1 is just going to give you negative 1. It's going to be 0 minus 1. It's a little bit confusing, but that's how that works. Transaction amount, transaction. And so just to make sure we understand the logic, so don't close out, and then we'll have to return the balance from this let loop. So we're going to start with a balance of 0. We're going to go through each transaction in the general register. If our balance, we're going to have to change our balance, we're going to add to it. If this transaction is debiting the account, and this is the kind of account that increases with debits, or if the transaction is crediting the account, and this is the kind of account that increases with credits, then we're going to add to the balance the transaction amount of the transaction. Otherwise, this account, since we already established that it has something to do with this transaction, otherwise we will subtract the amount of the transaction from the account. So let's do this. So let's see. What is the balance of our checking account now? So we'll say account balance, and now wait, I have to compile this function, Control X, Control E. So it's giving me a warning. So did I do something wrong here? I call this general register down here, but up there I called it general ledger. So thank you for that. I had an undefined variable, and yeah, okay, that was all. That was the only warning. So Control X, Control E, it'll just say warning redefining it, but that's okay. It's okay to redefine functions. I don't know why SVCL warned you about it. So we'll check the balance in our checking, and it's increasing with checking accounts increase with debits. So there we go, and it says our balance is 2,400. Well, let's take a look at our general ledger and see if I agree. So I've started with 2,000, I subtracted 50, I subtracted another 50, that got me to 1,900. I added 500, I got to 2,400. That is right. Now, if so let's suppose I add some transactions now that have nothing to do with this checking account. So now the crediting account will again be opening balances, but you know I'm adding a savings account. So I'm going to debit my savings account in the amount of $5,000. Oh, odd number of oh yes, that's right. I forgot to add I forgot to add this keyword here, amount 5,000. And now I have a new account that has nothing to do with D. So let's make sure that our account balance function isn't getting interfered by it. It's not, so we coded this correctly, or at least it seems like we did. There might be some bugs in here, but this small check right here tells us that we coded this function correctly. We've added this transaction. Well, let's check on the balance of my savings account. Okay. Savings account also increased with debits, $5,000. Excellent. So that's great, but I would like to actually just look at all of the transactions. I would like to look at all of the transactions in my savings account. So I'm going to make a function called account ledger of an account, and this one will just be, so we're again, it's the same sort of thing. We're going to loop over every transaction in the general ledger, and if, and the same sort of logic here, if either of these things are true, W, control, Alt W copies and Control Y pastes in Emacs, by the way. If either of these things are true, then I want to say accumulate the transaction, and accumulates a keyword in the for loop that will collect all of these into a list and return that list. Make sure I'm still recording. Great. And return that list. So now let's look at it. Account. So let's Control X, Control E. Okay, it says variable account is defined but never used. Is that right? Wait. Something must have. Accumulate that can follow. Huh. Oh, do I need to put a do at the end of this? Did I get my loop syntax wrong? There we go. Okay. Account ledger of our savings account should only have the one transaction. Oh, execution of a form compiled with errors. Compound form. Oh, never mind. Let's see, what did I do here? For transaction in general ledger, if this is true, yes, accumulate. Well, let's see. I already wrote this once, so let's see what I did wrong. In this one. Collect. Yes, that's right. Collect is the word I need to use. I'm sorry about that. I should have looked up my loop syntax before doing this. So collect transaction. And the collect keyword should collect this into a list and return the list from this loop. Now let's try this account ledger. Okay, yes, I saved it, but I need to compile it. Great. And we only have the one transaction in this list, and it is the only one to do with our savings. We do the checking. Same sort of thing. We have those 4 transactions, but not the 5th one from our savings account. Excellent. And in fact, that means that we can reset this. So instead of just 4 transaction in general ledger, we can say 4 transaction in the account ledger of the account that we're looking at. Which means we should probably move this up here. Control W cuts in Emacs, Control Y pastes. We'll move that before it, just so it's semantically speaking a little bit more reasonable. So for transaction in the account ledger now, and let's make sure that we didn't break it. So our account balance on our checking should still be 2,400. Excellent. And then the account balance on our savings is that. We'll check what our opening balances were. This opening balances is an equity account, so it increases with credits, actually. Increasing with the credit. it's not increase as with, it's increasing with. That is one of the disadvantages of using keyword arguments, is that you don't have to remember the order anymore, but you do have to remember how exactly you made the keywords work and things like that. But we can see, we started with $7,000 in our opening balances. So this is a pretty good system. Just using the property list, this is a fairly good mock-up of what things look like. Now, I want to focus on the dates a little bit. So again, the transaction date, I said that the date was in this UTC sort of Unix integer time. So, you can do, as we said, get universal time to get the integer corresponding to the time right now. Let's clear this out a little bit, and so things are a little less cluttered. But, occasionally you want to add dates that are, not the exact current date. So I had to look this up. This is in the Common Lisp Cookbook, which you can find online. I just have it open in this browser. So it says you can decode universal time, and if you supply it one of these integers, decode universal time, and if you supply it, we'll just supply it now, get universal time, it's going to return, what is this, nine values. So it'll return 9 different values, and these aren't printed, by the way. These are actually returned, and we can talk about how to use those later. But these 9 values will correspond to, so we have year right here, we have the month, the day, the hour, the minute, and the second, and then down here we have the time zone. So I'm in UTC -5 right now, Eastern time, Eastern Daylight Time. So that is, that's the current date, and that's how there's this handy function that decodes it for us, and there is one that encodes it for us. So we can just say, I just know it. Okay, so it's encode universal time, and then looking at the bottom, again, this sort of status bar at the bottom will give you a hint on how to write your function. So we start at the second. So the second. So let's say I want to encode midnight on a date. So the second should be 0, the minute should be 0, the hour should be 0. The date is, say midnight today, the 18th of April month, 2020. And then this will return the integer that corresponds to midnight on 2020. So we'll say define midnight at, same sort of thing. We'll say year, month, day, because that's a more natural way of specifying it. And we'll say encode universal time, 0 seconds, 0 minutes, 0 hours on the day of the month of the year that we were looking at. And this should be very useful for us. Midnight at today. Oh, did I? Code universal time, second, minute, hour. Oh, yes, I put this in wrong. 2020 418. We want to go from general to specific. I think that this is sort of corresponds to IEEE time or something like that. Okay, that's great. So this, in fact, encoded the same integer. Looks like we made this function correctly. Now, the thing is, in our register now, in our ledger now, if we wanted to add a date that came before these, well, it would just be pushed on, currently. The add transaction just pushes a transaction, so it'll be pushed onto the top. Well, that doesn't really make sense. I think we want the most recent dates first, dates further back second. So in the next video, I want you to, in between now and the next video, rather, I want you to think about the best way we could do that, the best way we could implement that to where this ledger makes sense, to where it's reverse chronological, which is how ledgers really work in real life. and that's what we will want from this application, and I will see you then.